In today's video we're going to explore how iron is made, and why some atoms are more likely to form ions than others. An ion is just a charged particle, so it could be a single atom like lithium plus, and fluorine atom as shown fluorine minus. As you've seen in another video on electron structure, ions are formed when atoms lose or gain electrons. And they do this in order to have a full outer shell, so that they're more stable, such as lithium and fluorine. If the atom loses and gains electrons, as it reacts with other atoms to complete its doublet or octet electronic configuration, this doublet or octet electronic configuration, or octet rule, refers to the tendency of atoms to prefer to have 8 electrons in the valence shell. The two atoms will produce a new product known as ionic compound. In the example here, the ionic compound is lithium fluoride. I will talk about ionic bond and ionic compound in another video. Now, one of the interesting things about the periodic table is that the group number tells us how many electrons the atoms of the group have in the outermost shell. So group 1 elements have 1 electron in the outermost shell. Group 7 elements have 7 electrons, and so on. In order to become stable, though, atoms need to lose or gain electrons until their outermost shell is full, but losing and getting electrons requires energy, so the atoms who only have to lose or gain 1 or 2 electrons are much more likely to do so in form ions, because it requires less energy. Metal atoms tend to lose electrons and form positive ion known as cation. For example, group 1 and group 2 elements, which we call the alkali and alkali earth metals, only have to lose 1 or 2 electrons to be a full outer shell, which doesn't require very much energy, so they easily lose that electron to become 1 plus ion and 2 plus ion. Non-metal atoms tend to gain electrons and form negative ion known as anion. The atom of group 6 has to gain 2 electrons, and group 7 which have to gain 1 electrons. Atoms that gain electrons will have more electrons than protons, and become negatively charged. Let's look at lithium. Lithium has 3 protons and 3 electrons. It has 1 electron in its outermost shell. Hence, it will be more energy efficient for lithium to lose 1 electron than gain 7 electrons to complete its outermost shell. As lithium loses 1 electron, it becomes lithium ion. We need to draw a big bracket to surround it, with a 1 plus charge draw at the top right of the ion. The 1 plus charge is to indicate the ion has 1 proton more than electrons, which carries 1 positive charge. Lastly, the chemical symbol of lithium will change from Li to Li+. If the ion carries only 1 positive charge, example, +1 or -1, there is no need to write the number 1 in the chemical formula. The non-metal atoms will gain electrons to complete their outermost shell and form an ion. Let's illustrate using fluorine. Fluorine has 9 protons and 9 electrons. It is 7 electrons at its outermost shell. It will be more energy efficient for fluorine to gain 1 electron than lose 7 electrons to complete its outermost shell. The chemical symbol of fluorine will change from F to F-. Hence, fluorine will gain 1 electron and become fluoride ion. Something to take note of here is that unlike cation, anion takes the root of the element name, and applies an I, D, E ending. This 1- negative charge indicates there is one electron more than protons. Next, let's look at oxygen. Oxygen has 8 protons and 8 electrons. It has 6 electrons at its outermost shell, so it will gain 2 electrons and form oxide ion. The electronic arrangement of oxygen will change from 2, 6 to 2, 8 with a 2- negative charge, which indicates there are 2 electrons more than protons. Its chemical symbol will change from O to O2-. Hydrogen can either lose electrons to form cation, or gain electron to form anion, depend on situation. Just like we can write chemical equations between different atoms, we can also write equations to show the gain or loss of electrons. For example, in the case of lithium, we could write that a lithium atom goes to form a lithium ion plus an electron. Or let's say we were looking at fluorine, we could write that fluorine plus an electron forms a 1- fluoride ion. Lastly, noble gases do not form ion, since they have a complete outermost shell. There is another type of ion, which is derived from a group of atoms. This type of ion is known as polyatomic ion. Polyatomic ion is not found in the periodic table, and we need to memorize ourselves. For example, nitrate ion, sulfate ion, and carbonate ion. However, some of elements in groups 3, 4 and 5 would have to lose, or gain 3 or 4 electrons, which would require loads of energy, and so this doesn't happen very often, and we generally don't see these elements as ions. Many ions are colorless, however, some ions are colored. We should notice that transition metals usually form colored ions. Most of these are cation, for example iron 3, and copper 2 ions. The colors of some ions in aqueous solution. A simpler way of investigating the migration of colored ions under the influence of an electric field is shown in Figure 1. Figure 1, to show the migration of purple permanganate ions under the influence of an electric field, we are using a strip of filter paper on a microscope slide. In this experiment, we are going to investigate the migration of ions towards oppositely charged electrodes. A small amount of aqueous potassium permanganate solution is placed in the middle of a piece of filter paper, which has been moistened with sodium nitrate solution. The function of sodium nitrate solution increases electrical conductivity. After the circuit is closed, a purple spot moves slowly towards the anode, caused by purple, negatively charged permanganate ions. A small amount of aqueous iron chloride is placed in the middle of a piece of filter paper, which has been moistened with sodium nitrate solution. After the circuit is closed, a yellow spot moves slowly towards the cathode, caused by yellow, positively charged, iron 3 ions. Colors of gemstones. Gemstones are very rare minerals with attractive colors. Colors of gemstones are due to traces of colored ions. Some examples are given in table.